And practice problem number 4. So associated with sample problem F. So a pet store supply truck, you know, those things, moves at 25.0 meters north. So apparently all we can tell is directly north along a highway. Inside, a dog moves at 1.5 meters per second at an angle of 35.0 degrees east of north. That's a very unsafe pet supply truck. What is the velocity of the dog relative to the road? So again, boom, this is a relative motion problem. We have two different velocities. One of them is operating at a specific angle. And we're going to need to use our relative motion skills along with some resultant skills, right? Some triangle action going to happen here again. So because we're going to be doing motion, let's make sure that we have our coordinate systems defined, right? Plus, plus, minus, minus. And let's describe this motion with a diagram. Makes it a little easier. So first we have this velocity vector going here north, right? North, east, south, west, just for clarification. And this velocity is, what is it, 25 meters per second. And this is a velocity of the truck with respect to the road, or maybe you could say ground. Maybe that would be just as fine, but I'm going to use road. Oh yeah, because the question actually says road, right, relative to the road. So, but this is the velocity of the truck with respect to the road. Then inside, right, inside that, we have this other motion. If I just continue this up to show the rest of that y-axis, we have another velocity going and this angle, okay, is 35.0 degrees. Yeah, and it's east of north, right? North is straight up, and so east is going to be down that way. So that means that this is 35-degree angle, not this. Okay, so you got to be careful when you're doing that. So what we have here is one vector that just has y. It has a y component. There is no x component, right? There's nothing that's going this way. We have a second triangle. I can draw a little bit bigger here, where this, what do we call this? Velocity of, the dog with respect to the truck. I mean, I don't respect these contrived premises, but velocity of the dog with respect to the truck. Okay, that's that vector right there. What is that? 1.75 meters per second. And so in this resultant, there's going to be a y component of this velocity, and there's going to be an x component of this velocity. Remember, this is the angle that is 35 degrees. Mm-hmm. And so what we're going to do in general is we are going to need to figure out the velocity. Now, velocity is a vector quantity. Okay, remember we got magnitude and direction. Okay, so we're going to end up using the Pythagorean theorem and the inverse tangent function. Let's see. Total displacement. I'm sorry. I started saying that weird. Right? Total displacement. Or, sorry, velocity. Resultant velocity. So we have the velocity of the dog relative to the road. All right, so dr is going to be equal to the velocity of the dog relative to the truck plus the velocity of the truck with respect to the road. So how are we going to actually set these things up here? To start with, the to get this resultant here, what we need to do is again, imagine these are two triangles. Even though this triangle has only y displacement, it has no x displacement. And so in this resultant here, that maybe it should be v. Maybe we should call it v. Anyway. But this velocity of the dog relative to the road, the only movement in the x direction is due to the dog. Okay? Now, therefore, that little symbol means therefore, by the way. So the velocity, the total velocity in the x direction is only due to the velocity of the dog. Okay? So the x component of the velocity is equal to the velocity, again, in the x direction of the dog with respect to the truck, right? Because that's the only situation in which something is moving in this x direction. The truck itself is only moving in the y direction, so there is no there's no x movement there, motion. So we know that we can we can solve this with 1.75, right? 1.75 meters per second. But we have to take the sine of the angle, right? Because we only want the opposite side, right? Here's the angle, 35. Oh, sorry. I was off the camera. So here's the angle, 35 degrees. The x component is opposite. Okay, it's opposite. It's right here. It's opposite the angle. So it's going to be the sine of 35 degrees. And that'll give us the x component, right? The x component. And that will actually be the total velocity in the x direction, because there's nothing that's going to be added by the truck, by the pet store supply truck. And so when I pump this into the calculator, it comes out to be 1.00 meters per second. Okay, so that's going to be one side of our new triangle that we get to calculate the resultant at the end. The y, we're going to have two different y components here. You got this y component, and then you also have this y component. Oh, I guess that would be up here. So we're going to have to add together. Ooh, I'm running out of room. Maybe I shouldn't write so big. But so the velocity total is going to equal the velocity of the truck with respect to the road, because it's only y direction, plus the velocity, but only in the y direction, of the dog with respect to the truck, because the dog does have movement in the y direction. So we need to figure out what this thing is. So this thing plus that thing will give us our total y velocity. So let's figure out this thing first, because the velocity of the truck with regard to the road is actually given to us by the question, so we actually need to figure out what this is beforehand. So I'll do this over here to save some room. So velocity in the y direction of the dog with respect to the truck is going to be equal to the again, the total velocity of the dog, which is, again, 1.75 meters per second, just like it was here. But just like up here, I need to take into consideration the angle. Okay, and so here I'm going to use the cosine of that same angle, 35 degrees. Not a very good looking 5, but that ends up being 1.43. I want 3 sig figs, right? Yeah. Okay, so I'm gonna plug that in there. So I end up with, again, pulling from the question, this is 25.0 meters per second. So 25.0 meters per second plus 1.43 meters per second. Again, I got that from here. That's going to end up being 26.4 meters per second. All right, so I have, where is it? Oh, so I have an x component of my overall triangle, right? And a y component for my overall triangle, right? So total x, total y. So let's draw, I might actually flip this over on the other side of the paper just to have enough room. I did not paste this out correctly. But let's draw our resulting triangle. So we have 26.4 meters per second. Okay, my total. And I have an x total, 1.00 meters per second. That's my x total. And what I'm actually going for is this. That result in the velocity. Let's go. Cool. Am I gonna get in trouble if I do that? Maybe. I'm gonna call it the total velocity, right? Velocity of the dog relative to the road. That's a better way to do it. Dog relative to the road. Let's do that. All right. Well, because we have set up a new triangle, okay, that it has a nice right triangle there, turns out the magnitude of this velocity of the dog relative to the road can be solved using the Pythagorean theorem. So, know that. Well, that's how I would normally write it down. So I'm gonna write it down using that representation. So don't freak out, please. So that's going to be the total x velocity squared plus the total y velocity squared, all square rooted. Okay, that should look pretty darn familiar. I'll plug in some values here. So 1.00 meters per second squared plus 26.4 meters per second, all squared. All of that is going to be square rooted. So that ends up being 1.0, right, because it's squared, doesn't change it. But it's going to be meters squared over seconds squared plus, big number, 697 meters squared over seconds squared. Don't forget the radical because it's still square rooted. But let's add those like terms. I like to do that. It makes it a little bit easier on the calculator work. 698. That was easy. I could have done that in my head. Meters squared over seconds squared. Still square rooted. Not a very good radical, but you know, hopefully you guys forgive me. Square rooted. That ends up actually coming back to, when I use the appropriate number of sig figs, it's still 26.4 meters per second. You might be annoyed that it ends up being the same as the total y, but that can make sense because look how small the x component of this velocity is compared to the y component. So it makes sense that the resulting velocity is going to be very, very close to this. So close that it's actually not enough to round this, up to like 26.5, or should I say, round this up to 26.5. So that's the magnitude. I still need the direction, right? So the angle at which that is moving. So I'm going to use my inverse tangent function. You guys know that it's going to be opposite over adjacent. So here is that angle I'm talking about here. So opposite over adjacent, opposite over adjacent. So that's going to be 1.00 meters per second divided by 26.4 meters per second. And to 3 sig figs. That ends up being 2.17 degrees. And so here's north, perfect north, and this is going to be east of north, right? It's moving that way. East of north, so I'll write east of north. So if you were just to look at the movement of the dog relative to the road, moving 6.4 meters per second at 2.17 degrees east of north. And also, you need to secure your dogs in the pet store supply truck a little bit better. I think someone needs to get fired.